So let's start the next session. That is, what are the different components of CNC machining island? See, this is a robot named Mitsubishi Robot RV4FN. This robot is a 6-axis vertical articulated industrial robot. This robot is having 6 joints. That means J1, J1, J2, J3, J4, J5, J6. This will be look like a human hand. The main job of this robot is to do pick and place, machine loading, assembly, material handling, packaging, etc. So this is an industrial robot with a 6-axis. Let's see the main specifications. So the main specification of this robot is position accuracy will be plus or minus 0.02 mm. That means if the robot is going 100 times in one location, the maximum error will be only 0.02 mm. The repetition accuracy for the robot positioning is plus or minus 0.02 mm. That means the maximum error will be only 0.02 mm. So this is very much, this is a very high accurate robot. And its maximum speed is about 9,900 millimeter per second. That means this will work very quickly. For monitoring, we have end position monitoring and overload monitoring. There is an end position and overload monitoring. This is solely for monitoring. See, what do you mean by end position monitoring? End position monitoring means it will check whether the robot reaches to the end position or not. That is what is called the end position monitoring. Then overload monitoring means if this overload monitoring means it will check whether the robot has taken too much weight, or check that will check if the motor is overloaded or not. And the maximum reach of the robot arm is 648.7 millimeter. That means from base to tool, this is the maximum distance the robot can reach. Then coming to the performance. So this robot is having 32 digital inputs and 32 digital outputs. So this input and output is to communicate with the PLC. So this robot is having 32 inputs and 32 outputs. So it will communicate with the PLC. So maximum reservation will be one workpiece or pallet. That means At a time, robot will handle only one pallet or only one workpiece. Then let's see the drive unit. That means the front panel. So this is the controller. This is the robot controller. That means this is the brain of the robot. Okay. So the complete control of the robot is from this box, this black box. This is the controller. And we will start one by one. There is one red button. This is what is called an emergency stop. If you press this emergency stop, the robot will immediately stop. Then we have a down button to go to the below bottom position in the menu. Then there is a button called a CHNG. CHNG means to change the parameters, that is change button. Then the fourth one will be the display. That will be the controller display. Here we can see the status, error, program, everything we can see here. Then number 5 will be the key switch. Key switch. Okay, having different modes such as teach mode, auto mode, external mode, etc. So teach mode means we can teach the robot. Auto mode means the program will execute. Robot will execute the program autonomously. External mode means PLC control. Then USB cover, USB plus battery interface. Then teach pendant connector. Here we can connect to the teach pendant. Then number 8, servo on. Servo on means motor power on. To move the robot, we have to turn on this servo. Then servo off. The servo off means motor power will off. So robot will be in a locked position. Start means to start the program, and up button means we can go to the top position in the main menu. Then we have a main switch, right? So main switch is to turn on or off the motor controller, sorry, robot control. Then end button, menu exit. To clear alarm, we have a reset button. We can reset the error. Stop button, that is used to pause the program. This is not emergency stop. So we have emergency stop and we have stop button. Emergency stop means if you press this, the robot movement will stop immediately. The stop button means to stop the program. This is not emergency stop. Okay, so this is the front panel. Then we will see the rear panel of the robot. Okay, so here we can see different ports. CN1. Okay, so CN1 is this is the robot cable actually. Okay, this is robot cable CN1, CN1 and CN2. CN1 and CN2 means robot cable. Robot cable 1 and robot cable 2. Then number 3, CN user 11, optional communication. CN user 12, again, optional expansion. CN user 13, special interface. Then we have a number 6, slot 1, digital input output. That means we have mentioned how many inputs and how many outputs. So number six, number six, input output 0 to 15. Number seven, slope to input output 16 to 31. Then CN user 2. Then number 9, Ethernet port. So we can connect this to PLC network, MES, programming PLC, PC, etc. So this is what is called a teach pendant. Okay, so we can teach the robot using this. Actually, in a TV we have remote control, right? So we can control the TV. We can change the channel. We can turn on or off the robot. Sorry, off the TV, right? So same way, just imagine this is the remote control. The teach pendant is the remote control of the robot. So using this, we can do so many things like a job, program, origin, errors, reset, run, etc. So this is having three different modes. One is OP mode. Here it is showing OP mode, then standalone mode. So OP mode means a standalone mode, and so a robot will work uh, itself. And EXT means PLC control. Then teach mode. Teach mode means manual teach. So using this teach pendant, we can move the axis. We can record different positions. We can edit the program. We can set the origin, etc. So uh, as I have already mentioned in the robot controller, so this one, in the robot controller, we have the emergency stop, right? Similar to this, we have emergency stop in teach pendant also. Here, this one. This one is the teach pendant. Okay, if you press this, the robot will stop immediately. Then we have a display here. In the display, we can see what is the status of the robot, access position, errors, program, everything we can see. Then coming to the next one, standalone connection. Okay, how we can connect to the robot, right? So this is our robot. Okay, so this is the controller, right? Okay, so we have mentioned we have two cables, right? CN1 and CN2, right? We have two cables, CN1 and CN2. So the CN1 and CN2 is connected to the robot, from the controller to the robot. So this 3 represents, this is the drive unit. Okay, so number 4, this is a 50-pin cable, RIA box, controller communication. Number 5, RIA box, robot interface adapter, external input output, and also PLC communication. Then programming connection. So this is our teach pendant, right? Okay. So this is our Ethernet cable, right? Then this is our drive unit. Okay. Then this one, third one. This is the programming PC. So programming PC to Ethernet cable, it will goes to the drive unit, right? Then teach pendant, right? So in the teach pendant, then programming software, robot controller, robot. This is the programming step setup. So once again, this is our programming PC. Then Ethernet cable connected to the drive unit. Then from drive unit connected to the teach pendant. So programming software, robot controller, robot. This is the programming step. Okay. Then coming to this one, this is showing the PLC interface. This is very important. PLC, robot controller, communication mapping, everything will be here. Okay, so here we can see input, right? This is showing input. So what do you mean by input? So input means the input of PLC, right? Here, if I say input, here I say input, output means input to the PLC, output means output from the PLC. Okay. So what is the meaning of this input? This input means this is the input to the PLC. That means from robot to the PLC. That is the meaning of this input. So input means from the robot to the PLC. So for example, so door open, right? So here you can see, okay, in the CNC milling machine of the door open, door closed. Okay, so this is the input. Now door open. So this is the input. This will send to the PLC, right? Door open, door close, voice open, voice close. Robot is ready. That is the input. Servo on, right? Servo on, servo off. Any alarms? Then program running, teach mode, battery low, error override, program number, etc. Okay, so as you can see, this is the input, right? Then okay, so here also you can see input, right? Then we have output, right? So what do you mean by output? So output means here output means PLC to the robot. Okay. So in this PLC system, input output means every time when your input means input to the PLC and output means from the PLC to the robot or PLC to the machine. Okay. So so output so output means from the PLC will send a command to the machine. Right. For example, open the door. Right. So PLC will send a message to the machine. Open the door. Close the door. Open voice. Close voice, etc. Okay. Start CNC, stop CNC, etc. Yeah, here also you can see output. These are the output, right? Output. So reserved bytes for future expansion. Now not using. So the communication flow will be PLC, start signal, robot controller. Robot controller, servo on, robot ready, program start, robot move, task complete, robot ready, PLC next command. Okay. So after learning this, now you will be able to understand the specifications of the robot, right? Specifications of Mitsubishi Melfa Rv 4FL robot. What are the specifications of this? And then the different buttons and ports of CR750D drive unit. And also you will be able to understand the use of each pendant, this one, each pendant. The robot can operate in standalone mode as well as PLC mode. Then we know the PLC robot input-output mapping. So through this, you will be able to understand how the communication between CNC machine, PLC robot. Okay, so next is what is called a parameter. So, so these are the parameters. Now, for example, when we are going to configure the CR750D controller, robot controller. So these are the parameters we should give initially. So for the configuration of a new drive unit, you have to adjust the following parameters. After the configuration, the drive unit has to be switched off and then switched on again. So what is the use of this parameter? So what is the use of this parameter? If you changed this to a new drive unit, this is to recognize, this is to identify robot. This is to communicate with PLC, connect with the Ethernet camera. Also, we can load the program. So once we uh, change the parameters, okay, once we have completed the configuration, off the system and again turn on the system. Okay, then only the new settings will come, will be in, will then only the new settings will be activated. Then only the new settings will be activated. Then only the new settings will be activated. Okay. So we have tool offset. So what do you mean by tool offset? So tool offset means we have a robot tool, right? That means gripper. And we have a real tool center point, TCP, right? So we have to inform the controller where is robot tool gripper and where is the real tool center, TCP. Okay, so we will be informing the controller that, okay, here is the tool center point. Okay, we should inform. That is what is called a tool offset, tool center point. So we are going to inform the controller that, okay, so where is the tool center point? That is what is called a tool offset. Then we have communication parameter. So for example, if the gripper length is 150 mm, okay, we have to give the offset as from the robot flange to tool tip. Okay, so the values MEXTL1, MEXTL2, MEXTL3, MEXTL4. These are the offset values. So we are informing the controller that where is the tool center point? Where is the tool center point? And next is the communication parameter. So communication means communication between PLC, right? PLC robot communication, right? So who is communicating with the robot? Who is communicating with the robot? PLC. PLC is communicating with the robot, right? So for example, start 2001. That means if you on PLC address 2001, robot program will start. Then stop 2000. PLC stop command. Then servo on 2004. This is the communication by servo on, servo off. Servo on 2004, right? Servo off 2005. Servo on off means motor power on off, right? And then error reset 2006. Robot alarm reset. PRGSEL to select the program. PRG out. This will send the program number to the PLC. Then error out. Robot will send the error code to the PLC. IO data. IO data means robot data exchange. Then we have communication parameter, Ethernet camera parameters. This is related to the camera network settings. For example, camera IP address 192, right? Then 168.x.x, port number 1000, like that, 10001, like that. Then we have slot parameter. This is to run automatic programs during the robot startup. For example, monitor home, robot home position monitor. Then ENG, RS save VAC, vacuum save program. Monitor PLWS. That means pallet monitoring. Then coming to the programs and the error messages. So main programs, at least two programs should include in the controller. At least two programs should include in the controller. So program 1, load CNC. That means the robot will load CNC means the robot will take the workpiece and put that workpiece into the CNC. And program number 2, discharge the CNC. Discharge the CNC means after completing the machining, the robot will take the workpiece. Then return messages. Return messages means, yeah, we can say return messages means error messages. Okay, this is to understand the robot error code. So error 1, robot gripper closed. That means gripper already closed. Error 2, security doors open. Security door open. Okay, like that. Error 11, unidentified type of gripper. Error 21, unknown stopper. Stopper position not able to identify. Error number 22, no program number. PLC is calling a wrong program. Error 31. Camera will not see the workpiece. Camera vision failure. Error 41. Workpiece mounting position is busy. That means that place is already occupied. Error number 42. No workpiece. Error number 43. Part wrongly placed. Error number 44. Alignment is wrong. Error number 45. No PCB. No board found, right? Then 51. PCB tray alignment is wrong. Error number 52. Unknown PCB pallet. Error number 53. Requested pallet empty. Error number 54. Board already available. Error number 61. Magazine empty. Then 62. Magazine number is wrong, right? Unidentified number of security magazine. 63. Magazine full. Okay, so next is robot positions. Okay, so we have P done POS. Okay, P done position means after completing the robot task. And P home means home position. That means this is the robot safe position. After executing any program, the robot will come here. Okay, this is the home position. After executing the program, the robot will come here in this position, P home. And P box pallet origin. This is the pallet origin. This is the reference points of all coordinates. Then P box pallet dir. Pallet x dir. X dir means x direction. Then y dir means y direction. Y direction of the box. Okay. Then xy means xy direction of the box. XY direction means what will be XY direction? XY direction means the diagonal reference, right? So the position P box palette X direction, Y direction, and XY direction are calculated, and you cannot reach them. So actually, controller will automatically calculate all these positions. No need to teach them. Which one? X direction, Y direction, and XY direction. So next is the two-quadrant controller. This is the conveyor motor controller. This one. Two-quadrant controller is the conveyor motor controller. Okay. So what is the duty of this two-quadrant controller? So 24-volt DC, forward, reverse, stop, slow speed. Everything will be controlled by this two-quadrant controller. This is having brush DC motor, conveyor, So the use will be for a brush DC motor conveyor solenoid valve. So the feature of this will be clockwise rotation. Clockwise rotation means conveyor will move to move forward, right? Counterclockwise means conveyor will move backward. So slow speed is for inspection, right? And another plus of this is that temperature protected, right? Short circuit proof and temperature protected. Short circuit protection. Okay. Then coming to the technical data. So see the main specifications. The power supply will be 24 voltage, right? So the nominal voltage 24, right? So power supply is 24 voltage DC, right? 24 voltage DC, right? And motor current will be 3 to 5 ampere, and maximum current will be 20 ampere, right? And the temperature range is from -20 to 40 degrees Celsius, right? And weight is 100 uh, 100 gram, right? Protection, temperature protection as well as short circuit protection. Okay. So coming to the connection diagram. So see the connection diagram A1. So this A1 is clockwise, right? Conveyor drive unit clockwise rotation, and then A2 for counterclockwise. Then A3 for slow speed, right? Then A4 stop, 24 voltage power supply. So so this represents 24 VC power supply, and the G and D, this is the ground, negative, right? This is positive and this is negative. M is the motor connection, conveyor motor connection. So this Q 0.4, that is the clockwise, right? This is the PLC output actually. And Q 0.5 counterclockwise, right? And Q 0.6 0.5 slow speed, and 0.6 means stop, right? Okay. So this is our main controller. Okay. So this is the Siemens controller actually. This is Siemens Simatic PLC. This is the main controller of the CP factory. So the main job of this PLC is to read sensors and execute the logic and give output commands from the PLC to the robot, or robot command or conveyor command, camera, if there is camera command, HMI communication, MES communication. So this is the brain. This is the brain of the entire CPU system. So this is showing the Siemens touch panel, Simatic TP700 comport. This is what is called HMI, human machine interface. So the operator can start, stop, reset, alarm, manual, auto, production count, error message, everything. All the information will be available here. And the specification will be 24 voltage DC, right? And the power will be 12 watt, and the processor will be x86. And memory, flash memory, RAM, yes, user data memory. And coming to this one, this is Scalance Ethernet switch. This is the industrial Ethernet switch. So the main job of this switch is to connect everything, right? So we have PLC, we have a robot, we have HMI, we have camera, we have MES, programming PC, industrial network. So connect everything using this Ethernet switch. So this is having 8 RJ45 ports. This is like a plug and play ports. Okay, no need to do any settings. Just plug and play. Just plug and play. We can use it directly. Then coming to the properties of Scalance X208 properties. This is the network features. As I have already mentioned, RJ45 ports. This is the standard Ethernet, and the maximum cable length will be 100 meter, right? Sorry, 10 meter, right? Yeah. So, cable length is 100 meter. So auto negotiation, switch will find itself. Speed will be 10/100 Mbps. Duplex mode communication settings. Then auto MDI or MDIX. This is the main feature. So in traditional switch, PC to PC, switch to switch, we need crossover cable, right? But in Scalance X208, we can use straight cable, we can use crossover cable. So switch will identify itself. So one of the main important point is that do not connect same switch two ports using the cable. If you connect it, what will happen will be network loop will happen. So because of that, network will hang, communication failure, PLC communication will lose, and the robot communication failure will happen. So, so we have learned different drive unit parameters, right? So we have learned different drive unit parameters, so we can configure the drive unit parameters. Also, we should understand the communication between PLC and robot. Using the robot error code, we can using this is the robot error code, right? So using this error code, we can do the troubleshooting. And also we should be able to understand the robot positions like the home, done, pallet origin, etc. And also the conveyor motor controller wiring. This is the conveyor motor controller and its wiring, right? And also PLC, Siemens PLC, and our HMI, human machine interface, right? And we have Ethernet switch. So the complete working of CP factory will be PLC, then we have a switch, right? Then robot, HMI, camera, MES programming. Okay, next is RFID with the Ethernet. Sure. RFID Ethernet module. So first of all, what is RFID? RFID means radio frequency identification, right? So using RFID tag, this is to identify pallet or workpiece. This technology is what you're using this RFID technology. The system can identify using the RFID tag. the system can identify workpiece or pallet. The technology is what is called RFID. So the working will be like this: in the pallet or in the workpiece having RFID tag. So RFID reader will read that tag, right? And then whatever information RFID reader will read, it will communicate to the PLC through Ethernet. Then based on that, PLC will take the next decision. So let's take one simple example. If in the pallet having an information, say product A, in the RFID tag, so PLC will send that to the CNC machine. Then next is the RFID wiring. This is showing the RFID wiring. So here we have the Turk read write head. So here, this one, this yellow color, this is what is called a Turk read write head equipment identifier. Then we have a connection cable. So then we have a connection cable, this number 2 cable, from the head Turk read write head to the Turk module. This is the Turk Ethernet RFID module connected to this. So the working will be like this. So for example, if the box is coming, then the RFID having RFID tag. So this RFID head will read it, and through the Ethernet module, it will be communicated to PLC, and finally it will be communicated to MES or HMI. So then we have this is what is called a RFID read write head. Okay, so this is our RFID reader actually. Turk, this is what is called a Turk RFID read write head is mounted on the shift unit. So the main specialty will be the supply voltage will be 10 to 30 VDC, and the current will be 80 milliampere, and working frequency 13.56 megahertz, and the maximum reading distance will be 115 millimeter. So what is the duty of this reader? So this will read the tag. Okay, this will read the tag, and also it will write new informations to the tag, and every pallet is having a fixed identity, right? So that those identity will be sent to the PLC, right? Next is what is called electronic circuit protection. This is MER micro electronic circuit protection. So the main job of this electronic circuit protection will be if there is a short circuit is happening in the circuit. Okay, no need to switch off the entire machine. So if wherever the problem, okay, only those circuit will turn off. That is what is called a electronic circuit protection. No need to turn off the complete machine. So the advantage will be PLC will become safe, power supply will become safe, sensors will become safe. We can reduce the downtime. Then coming to the circuit protection specifications. So coming to the circuit protection specification, the input voltage will be 24 voltage DC. And the operating range, 18 to 10 to 30 VDC, right? The current settings, 1 ampere, 2 ampere, 4 ampere, 6 ampere. Operating temperature 0 degrees Celsius to 55 degrees Celsius. That will be the operating temperature. The current adjustment 1 ampere, 2 ampere, 4 ampere, 6 ampere by counters in the rotary switch. Next is the power supply unit. So this is the power supply unit that provides 24 voltage DC power supply to the station. So input will be 100 to 240 voltage AC, and the output will be 24 voltage DC. So using this power supply, we can operate PLC, HMI, RFID sensors, solenoid valves, and a safety relay. Then this power supply specifications. Let's see the power supply specifications. Yeah, the input voltage will be 100 to 240 voltage AC, and the output will be 24 voltage, 24 voltage DC. So input will be 100 to 240 voltage AC, and the output will be 24 voltage DC. And the maximum current will be 10 ampere, frequency 45 to 65 hertz. And the operating temperature is from minus 40, sorry. Yeah, operating ambient temperature minus 25 to 70 degrees Celsius. Then we have a safety relay. This is a very important safety device. If you press the emergency stop, or if you open the safety door, immediately robot conveyor motor will stop. So this will be used to make sure that the operator will be safe. Safety relay. Then we have mini terminal. So this mini terminal is actually a connection distributor. So we can connect the wires of sensors, actuators, everything we can connect into this mini terminal. Here we have M8 connectors, right? LED status indicators, 15-pin D-sub connector. So the pin allocation, pin 1 to 12. Pin 1 to 12, right? So the signal lines, pin 1 to 12. Then pin 13, DC 24 voltage. Pin number 14 and 15, OV. OV means ground. So next is multi-pin distributor MP1. So we have PLC, right? In the PLC, we have input output, right? So the PLC input is connected to the sensor and PLC output is connected to the actuator, right? So in this table, we can see which input is connected to sensor, which input is connected to actuator. So for example, MPV1, stopper 1 down, right? Stopper 1 down. Okay. palette available sensor, right? Then identity sensors, etc., right? So this is MP1, right? Multi-pin distributor mapping. Then multi-pin distributor MP2, MPV2, stopper to down, stopper to up, congestion bypass, identity sensors. So when we program the PLC, this mapping is very important. Okay, so we have discussed. So what are the topics we discussed? Let's see one by one. So we have discussed this RFID, right? So we have discussed the RFID system, right? So RFID will identify each pallet or workpiece or box, right? We have RFID reader. This is the RFID reader. This will read the RFID tag. Okay, this is what is called a read write. So this will read and also it will write. Then we have a cable, right? Ethernet RFID module, right? It will send the RFID data to the PLC. Then we have electronic circuit protection. It will protect the circuit short. It will protect the machine from short circuit, right? And power supply will be 24 voltage DC. We have a safety relay, right? So this is our power supply unit. So this power supply unit will provide 24 voltage DC to all the components. And we have a safety relay, right? So this safety relay is for emergency stop and it will observe emergency stop and safety door. Okay, if any um, safety related issues, it will stop the machine. Then we have a mini terminal, right? So this is our mini terminal to connect sensors and actuator with the PLC, right? So sensor is connected to the PLC input, right? And the actuator is connected to the PLC, right? So this is to so this mini terminal is used to connect sensors actuators with the PLC. So this is the multi-pin distributor mapping. So every PLC input output. So this input output is connected to which sensor or which actuator connected. So that is mentioned here. So next is multi-pin distributor MPV3 and MPV4. That means this will receive input signals. So for example, bit 0, stopper 3 down. Bit 1, stopper 3 lower sensor. Bit 2, palette available, identity sensor. Bit 4, identity sensor 2, like that. So it will, what is the present situation between PLC stopper and a palette? Then MPV4 XT50. This is to observe pickup position. So for example, bit 0, pickup position 1, palette not available. Bit number 1, pickup position 1, workpiece not available. So other bits are reserved. Next is what is called a connector pin assignment. So this will shows the connector pins of the station, right? So it is connected to the PLC through one connector, right? So during the wiring, this will be used as a reference actually. Next will be the syslink reference. So syslink, syslink not reference, syslink interface. So this is the communication interface between PLC and station. So the left side will be output bits, right? 0, 1, right? 2, 3, 4, 5, 6, 7, right? So using this, PLC will run the conveyor, run the solenoid, move the stopper up, etc. Give robot command, etc. And in the right side, this shows the input bit. Okay, so this means, so what sensor will give information, right? Okay, here, whatever information sensor will give, that information will read here. Okay, for example, sensor on, sensor input bit on, PLC program will work. So power pins 24 voltage and OV means OV, not OV, 0. 0 means ground. So this interface will give the power. Then we have our conveyor motor of conveyor, mechanic components. This is the geared motor, geared DC motor to run the conveyor belt system. The job is to, so motor, gearbox, roller, so conveyor belt. So when the conveyor belt is moving, pallet will move, right? So the information will be "24 voltage DC, gear reduction, high torque, low speed, conveyor drive. Check the motor sound. Check any gearbox oil leakage. Belt slip. Check coupling loose or not." Then we have the stopper unit. This one. This one is the stopper unit. So this unit is to stop the pallet in the conveyor belt system. So the main parts will be RFID read write head, right? This one, number 1, Turk. Then pallet sensor 1, then pallet sensor 2, pallet sensor 3, pallet sensor 4, right? 1, 2, 3, 4. Then we have the stopper, number 5. Sorry, not number 5, number 6. Here the number is 6, right? So number 6 is the stopping unit. And here we have the pneumatic cylinder, right? This one, number 7. Pneumatic cylinder. Number 8, stopper position sensor, right? Then number 9, this is the one-way flow control valve. This is the flow control valve. So for example, if the pallet is coming like this, okay, if the pallet is coming, so sensor will detect this, okay, then the cylinder will extend. So the cylinder will extend and the pallet will stop, robot will pick, then cylinder will retract. Okay, when the cylinder will retract, the conveyor will go. Yeah, this diagram is showing the pneumatic diagram of the stopper. This is the pneumatic circuit actually. Here, this is the diagram of pneumatic stopper unit, right? Here we can see the air supply, solenoid valve, cylinder flow control valve senses how everything is connected. So the working will be very simple. PLC output on. Okay. When the PLC output on, solenoid valve on, right? So compressed air will go to the cylinder. Then the cylinder will extend and stopper will move up. PLC output off. Change the valve position. Air will reverse. Then cylinder retract. Stopper down. Yeah. Next will be the transportation of the station. So this is what is called a station, right? How we can move the station, right? So we have a height adjustment knob here. Okay, then we have a roller and we have a lock nut, number 3. Okay, so first of all, lose the lock nut and adjust this height. Okay, and then move the station roller. Okay, then move the station to another location. Then again, down the feet, tight the lock nut. That's it. When you adjust the height, do not place your hand here, or also do not place your leg here. It will create serious damage to your hand or your leg. In the HMI screen, human machine interface, we will get 3 different types of messages. One is called class 0, class 1, and class 2. Class 0 means class 0 represents the uh, displayed red. Immediately program will stop. Operator should reset. This is the very uh, dangerous error, class 0. Then we have class 1, displayed red in the message line. Okay, this is warning actually. After completing the cycle, program will stop. Then class number 2, displayed yellow in the message line. This is only an information. Okay, yellow means it is only an information. This is a message to the operator. Okay, if there is an error coming on your HMI screen, you will get a pop-up on the HMI. For example, start not possible. Deposit position is occupied. That means deposit position is having pallet. So we have 3 buttons, right? So repeat, ignore, and abort. Repeat means we can try again. Ignore means we can avoid this. Okay, we can avoid this error when we can continue the program. And abort means we can completely stop the program. Then we have MES interactive error, right? One more button. See, for example, no part on deposit side affected after output. We can repeat, ignore, abort, right? Okay, and we have another option called a reject order. So reject order means we can cancel the order in the MES and process the next order. Okay, so we have discussed. Let's see. So we have discussed the input-output mapping. Then we have discussed our syslink communication, output input, right? Then conveyor motor, how conveyor is working, right? Then how stopper is working, right? How stopper is working, right? Then this represents the pneumatic circuit. Then how we can transport station from one location to another, right? Then what are the three different types of error messages we can see in the HMI screen, and how we can handle those type of error messages in the HMI. Okay, so that's all. Okay, so let's see the HMI screen. This is the human machine interface touch screen, where we can see our main menu, right? So in the main menu, we have home, setup mode, parameters, and system. So this is what is called the main menu. Main screen. Setup mode means we can control the system manually. If we need to change some parameters, we can use this option. To change language, time, user, we can use the system option. So in this home, where we can see the conveyor, right? So this is the conveyor, right? Okay, conveyor position, buffer position. Where is the position of the pallet? What is the status of sensor, right? Where is the stopper position? And we have a side menu. We have main menu. This is our main menu, and we have side menu, right? So in the side menu, we have operation mode, overview, user, and the input output test. This so this is main menu, this is side menu, and this is our graphic area. So this graphic area means we can see the live status of our station, where we can see where is the pallet right now, what is the status of the stopper, where conveyor is working or not, everything we can see. Then we have operating mode, right? So operating mode means we have different modes, right? One is setup mode. Setup mode means we can manually control the entire system. Automatic mode means the system will work automatically. And MES mode means using the manufacturing execution system. Then we have date and time shown here. What is the current date and time? We can log in this as an administrator. Okay. If we log in as an administrator, we can, if you want to use some specific functions, log in like administrator. For example, input, output test, user settings, setup functions, etc. So how to change your login? Go to home user. Okay, then press user dialog. Then after that, enter the username. After entering the username, enter the password. And in the manual, it is given that the username is Festo and the password is Festo. Okay. Once you log in, you will get access to the administrator mode. Then coming to the operation modes, right? So we have a reset. So reset means station will go to the home position. Once we will power on the machine, the first step is to reset. Okay, this is the first step. Once you power on the machine, press the reset button. Then we have setup mode. This is for maintenance. Here we can see the sensor details, cylinder conveyor movement, We can raise or lower the stopper, etc. Then we have another mode is called automatic mode. This is the production mode. PLC will control everything. Operator do not do anything. Then another mode is called MES mode. MES software will run the complete station, and every station will communicate through this MES mode. Okay, if you power on the machine, reset button will flash, right? So operator should press the reset button. So all the actuators will go to the home position. This is for safety and for position synchronization. And coming to the setup mode, this is for maintenance actually. Here we can see all the status of the sensor. All the cylinder we can manually operate, right? We can move the cylinder, we can do a troubleshooting. Here, box input. So what is box input? When the box is coming to the buffer, okay, we will be using this screen. Here we have left option, left, right, right. So left, right, slow speed, creep speed. So all the options we can control manually. Then ST1. ST1 means stopper. Stopper 1. So for example, we have stopper 1, ST1, we can raise or lower, manual operation. Then we have ST2. Yeah, this one is stopper 2, raise lower, manual operation. Then the status of the sensor. Green. Green means sensor on. Gray means sensor off. So green color. So green means sensor on and gray color means sensor off. So blue flash means output on. So here green is there, right? Green means a sensor on, right? Gray means sensor off. And blue flash means output on. Then next, so that was about box input. Then next is the box output. Okay, so we can send box from the buffer outside. Okay, so we have left conveyor, right conveyor, stopper. Here we have a stopper ST3, right, and ST4, right. Everything we can control. We have left conveyor, right conveyor, ST3, ST4. So everything we can control manually using this option. ST3 raise lower sensor status, ST4 raise lower sensor status. Conveyor direction left counterclockwise, right clockwise. So during the maintenance, we will be using this mode: setup mode, box input, box output, robot, CNC, input output test. Okay, so once again, we have discussed about the reset mode, right? So reset mode is for to reset the station. That means if you press this button, the station will go to the home position. Then the setup mode is for maintenance, manual maintenance, testing, troubleshooting. And automatic mode PLC will control everything. Then MES mode, using MES software. So all the stations we will control using the MES mode. In order to get some functions, yeah, in order to access some functions, we need to access the administrator login. We can control the box input and the box output. Right. So next we will discuss box shift unit within 2 minutes. So next one will be the box shift unit. Okay, here we are controlling the shift unit. So shift unit means from the conveyor box is coming, right? Okay, we can move the box from left to right or right to left. That option is what is called the shift unit. Okay, so by moving this shift unit, the robot can easily take the workpiece and place the workpiece into the CNC machine. So we can move the shift unit either left side or right side. Okay. Slow speed. Slow speed means pre-select slow. Creep speed means very slowly. Position sensor. Input position, output position, right, left position, right position. Everything sensor will show. Then RFID. Okay, so RFID means radio frequency identification. So using this, uh, uh, read all the informations from the box and also write informations to the RFID tag. So that is mentioned here, RFID. So initialize INIT. INIT means reset the RFID memory. Read means it will read the box data, and write means write the new data, and delete data means clear the data from the HMI. So now here you can see order number, right? Operation position, box ID, and the box process number. So when MES is working, these informations are very important. Then RFID status. On the right side where we can see ready, tag present, ready, busy, error, timeout. So during the maintenance time, we have to check whether the RFID reader is properly working or not. Okay. Then coming to the setup. So yeah, this one also we have discussed, right? The RFID. And coming to the setup robot. So we have mentioned we have a Melfa robot, right? Okay. So go to setup mode. Check the robot input signals. Okay. If the signal is showing green color, that means that input is active. For example, X stop to robot stop, X start, robot start, servo on, right? Then servo off. Ready. Ready means robot is ready. Error reset, battery error. So during the maintenance time, this will be very much useful. Then we have a robot output signals. Blue. So output signal means the signal coming from PLC to the robot. So from input signal means from robot to PLC. Output means from PLC to robot. Start, stop, servo on, servo off, error reset, program select, etc. Then we have an area called a program robot control area, where we can connect, retry, start program, exit cycle, etc. Also, the program number, source position, target position, offset, everything will shown here. After executing the robot program, success, error code, everything will be shown here, return value. So the main information mentioned in this page was, first of all, connect the robot controller. Servo should be on. The robot ready status should be activated. If you press the start program, then program will execute. If there is an error, you can use the error reset. If the robot is in teach mode, then automatic program will not work. Then coming to the CNC. This is the CNC machine manual control screen, right? Again, a green represents that active. Green means active. So auto, alarm, busy, referenced, right? So this shows the machine status. For example, door open, clamp open, clamp closed, DNC connected, CNC ready, etc. For communication, we have IP address, CNC IP address. Also, port number is shown. This is the communication between, communication means communication between the CNC and the PLC. Then we have different commands, right? Connect, start DNC, open door, load program, start, etc. So in the CNC program, here we can enter the number, nominal program number, actual program number. Okay. Next, showing the input output test. This is very important. Input output means this is to check the PLC input output. So we have green cell, okay. Then white, green cell input on, white input off. For example, if the sensor is in on position, then the color should be green. The color will be green. Then output orange. Orange means output on, white output off. So during the maintenance time, we can turn off the output force and check the actuator. Enable output. So on the right side, we have enable output option, this red button. If you press this, then only we can do the output force. But before doing this, administrator login is required. So this page is only for maintenance. If the sensor is not working, or if the cylinder is not working, okay, if there is a problem with valve, etc. So that time we can use this input output unit. Exit setup mode. So after completing the maintenance, press the home button, right, and then select the operation mode. Okay, then the setup mode becomes blue color. Okay, then press the cycle end. If you press the cycle end, then what will happen? Setup mode will stop. Now the mode is setup mode, right? So press cycle end. Then after that, we can select either automatic mode or MES mode. So which mode you want? So after completing the setup, press the cycle end. Then after that, you can enter into either automatic mode or MES mode. So the topics we discussed was in order to change any extra options, the administrator login is required. Press the reset button, right? Press the reset button and move the position of the station to home position, right? Then select the setup mode. try box input, box output, try shift unit, check the conveyor belt, sensors, RFID, etc. Then check the communication, robot ready, servo program, etc. Check the CNC connection, door clamp, program, DNC communication, etc. Check the input output test, sensors, outputs, inputs, valves, etc. After completing the maintenance or test, press the cycle end button, and then after that we can go to either automatic mode or MES mode. So next we are going to discuss the so yeah, we have discussed the majority of the buttons, right? So reset menu. For example, if you have pressed the emergency stop or if any error was happened, press the reset button. Automatic means the complete CP factory will work automatically. Robot, conveyor, shift unit, CNC, everything will work automatically. MES mode means the system we can control using the MES software. Setup mode means manual mode. Each and every unit we can check separately. Once we have completed a setup mode, then we can press the cycle end option, and then after that we can choose the either automatic mode or MES mode. So based on the mode selection will be based on the program. MES default mode means based on the PLC program. MES is not required. MES mode means MES software will control everything. So the station will work based on the production order. So here here we can see the overview of the screen. Here we can see the box input, box output, right? And shift unit, right? Then robot CNC box output, etc. So uh, for user management, we have three options: administrator, Festo, and PLC user. Every user is having its own username, password, and access level. If you log in as an administrator, you can add more users, change password, and also delete a user. And coming to the input-output test, this is very important during the maintenance. Input means input to the PLC, output means from the PLC. PLC in green color means PLC on. PLC input on. For example, sensor on, limit switch on. Output orange. Output orange color means output on. PLC output on. For example, cylinder is working. Motor on. Solenoid valve on, etc. Red means warning. Here we have another option called parameters. Here we can set application parameters. For example, application timeout. That means if you enter 500 seconds, so how much time required to complete one operation? We can set MES IPS web server. So it will allows communication with the MES server. If you tick this, MES communication will enable. Simulate robot process. Even though robot is not available, we can do the robot simulation. This is for training. Then coming to the simulation parameters. So robot simulation and CNC simulation. If you tick this robot simulation, without robot, software will work like a robot. Once you completed the simulation, confirm. Operator should confirm it. So how much time is required for the simulation? Okay, for example, 10 seconds. Same way we can do the simulation, enable, acknowledge. Also we can set the simulation time. So during the simulation, we can see the screen like this. Okay, here we can see the nominal time, then actual time, return value, progress bar. For example, a robot simulation, nominal time, say 10 seconds. Actual time, 1.18 seconds. Progress bar shows how much completed the simulation. Same way, CNC simulation, the CNC program number, processing time, return value, and progress. So this shows the progress. Here is the program number, right? Then coming to the settings, system settings, this is the configuration of HMI. Here we can calibrate screen, whether our touch screen is working properly or not. Otherwise, we can calibrate it. Then clean screen. Okay. So clean screen means if you clean the screen, touch will disable. Touch will not work. That is called a clean screen. Then we can switch language from English, German, etc. Transfer means HMI update or PLC program. System control is regarding the system settings similar to the Windows control panel. For MES communication, we have IP address and port number, resource number, query port. status mode. Everything we can configure. On page number 94, we have system settings. So calibrate screen to calibrate our touch screen. Terminate runtime means HMI runtime will close. Send a test mail means it will check the email configuration. MES IP address, that means MES server IP address. Clean screen, it will help you to clean your screen. That time your touch will not work. Language flag will change the language. System control, open the Windows settings. Transfer means HMI program update mode. So during the, say for example, during the maintenance of this, we will use the operation mode. So automatic setup, to change automatic setup, we will use the overview to check the status of each and every machine. Input output test to check the sensor output, PLC signal, etc. Parameters, timeout simulation, etc. System settings such as IP address, language calibration, etc. Okay, then this is showing the diagnostics, right? So here we can see the complete system error and diagnostic messages here. For example, here we can see the PLC errors, communication errors, robot errors, CNC errors, sensor fault, etc. We have different buttons here. Previous message, next message. So previous means you can see the previous error, next error. If you want to see the next error plus this arrow button. Home to go back to the home screen. If there is a configuration, we can send the error report by email. by pressing the send diagnostic mail. If machine is not working, check this first. Then coming to the software version. Coming to the software version, system software, go to system, then go to system software versions, HMI software version, PLC library version. It is showing V4.03. Here we have system backup. We have two options. Save parameters. It will save the machine settings. For example, the IP address, timeout, application parameters. That is, this is for backup. And another option is called restore parameters. So restore parameters means whatever parameters we have already stored, it will load again. The backup parameters we can load by pressing this restore parameters. If you reset your machine, or if you install a new HMI, we can use this option, restore parameters option. So coming to here, operation hours counter. Again, go to systems, this one, operation hours, right? This is very important. So go to system and operation hours. Here you can see how many hours the machine operated. How many hours we operated this machine. So total hours, we have total hours, right? That means the total hours machine was operated. Then in automatic mode, okay, how many hours work? Right, we have total, then automatic mode. And setup mode. Setup mode means manual or setup mode. How many hours this machine was operated. Then other modes. Okay. So this is regarding the time where the machine was worked in a different modes. We can reset the current record. This is useful to prepare the maintenance log. Then coming to here, we have the time zone PLC. Go to system time zone PLC. Here we can set the PLC's date, time, and time zone. If it is wrong, logs, production time, alarm time, everything will be wrong. Coming to the time zone HMI. Again go to system. Again go to system time zone HMI. It will shows the time of HMI screen. Mainly PLC time as well as the HMI time should be same. Otherwise, error time, email time, production log, everything will shows so we will get wrong information. So this should be same. PLC time as well as the HMI time should be same. Okay, next we are going to start the machine. Okay. So we should follow the step properly. Okay, we should release all the emergency stop button. Okay, check the machine, whether the machine is having any damage or not. Visual inspection, okay, if necessary. And after that, switch on the compressor. So in order to operate the machine, we need compressed air. 6 bar pressure is required, right? Then after turning on the compressor, switch on the main switch. Turn on the main switch. So if you turn on the main switch, HMI will starts and boots up. And after that, press the reset button, blue reset button. Then if you press this reset button, reset illuminated button lights up blue. Okay, check the HMI. If any error message was displayed on the HMI screen, click acknowledge. Okay, click acknowledge and clear it. Acknowledge the error message on the HMI screen. Okay. Next, we are going to see the Mitsubishi robot homing. Okay. If when you open the teach pendant, right, if any robot error, okay, first you should reset the error. Okay, plus there is a button called a reset button. Press this reset button on the teach pendant. Then you know the controller, right? In the controller we have two different modes, right? One is manual mode and another one is automatic mode, right? So when you use this teach pendant, you should change this mode from automatic to manual mode. Do not use the homing while the mode is in automatic, only in manual mode, right? Then press this button. This is what is called a robot teach pendant. Enable this teach pendant. This is what is called an enable button. This button is called an enable button. And behind this teach pendant, there is a switch called a Redman switch behind the teach pendant. Okay, only press half. Press half only. Do not press in full. Just press half only. Okay, if you press fully, it will not work. If you release it, it will not work. Okay, just half press. Press halfway and hold the dead band switch during the complete operation. So during the complete operation, you should press and hold this dead band switch. So in the half position only the robot will move. This is actually a safety feature. Then after that, press this. There is a button called servo, right? Press the servo button. Okay, so turn on the servo. If you press the servo, then servo motor will turn on. Okay, if servo is on, that means the robot can move. Okay. Then after that, step number 6, then go to the jog mode. Okay, in this jog mode, select the jog mode, right? So select the jog mode and we can move each and every axis manually using this jog mode. For example, X, Y, Z, A, B, Z, etc. So by controlling every axis, we can move the robot to home position. So remember what are the steps we have discussed. Release the emergency stop. Turn on the compressor. Switch on the compressor. We need 6 bar pressure. Okay. Switch on the main power. And after that, HMI will boot, right? And press the reset button. If any error will be on the HMI screen, click and acknowledge it. Okay, and change the robot controller mode from automatic to manual mode. Enable teach connect. Press the deadman switch off position. Turn on the servo, and then press the jog window and move the robot to the home position. So So now we are discussing about the robot homing, right? So using the teach panel, right? So select the appropriate, press the jog button and select the right tool. So tool number one, and then press this home. There is a button called home button. Press this home button continuously. So robot will move to the home position properly. So remember, select the tool correctly. Okay, and also make sure that when the robot is moving, nobody should be there. After after the robot has finished its movement, disable the teach panel. So this white color is the teach panel. Once the robot reaches the home position. After that, now the mode was manual mode, right? So the next step is to change the manual mode to automatic mode. Okay, go to robot controller and change this is the key switch, right? So change the key switch from manual mode to automatic mode. So if we change the manual mode to automatic mode, now the robot will be able to communicate with PLC as well as MES command. And make sure that this key on the CNC, okay, this is the FMS position. Okay, you should change this to position number one. So if we change this position to 0 to 1, then the PLC can control the CNC machine. Okay. So once we will change this to 0 to 1, PLC can control the CNC machine. Okay, now we are going to start our CNC machine startup. So first of all, uh, we have a PZ, right? Turn on the CNC PZ, right? And after that, you should wait till in NC software will auto start. And the machine type will be, we have three options. So the machine type will be HMI operate mill. HMI operate mill means human machine interface operate mill. Then the next step is make sure that your this application is called a WinNC application. So this WinNC is connected to the machine. Okay. So open this. Open the this name of this application is called a Start DNC. Okay, this is what is called DNC to MES software. This one. Okay, so turn on the machine. Then open this HMI operate mill, and after that open the DNC to PLC software. Okay, then here there is an option called Start DNC. Press this Start DNC. So if you press this Start DNC, now you can see. Uh, this can communicate to PLC, communicate to MES, etc. So communication will start if you press this Start DNC. Now we can see, check the connection, right? In the DNC to MES software, we have three connections. One is connected to ENCO, connected to MES, and connected to PLC, right? So green means it is connected. So that means this application is connected to ENCO, and also this application is connected to PLC. So PLC ENCO will communicate, but MES is not connected because the color is red, right? So the color is red means there is a communication error. Then go to this screen. Okay, here if you open the screen, okay, if it is connected, then here you can see DNC is connected. This one DNC is connected. Okay, then the next step is after this referencing. So So we can do the referencing in two ways. One is using WinNC software, and the second one is using DNC to MES software. So here there is an option called referencing. You can use this option, referencing option, or we can use this WinNC option software. Okay, so WinNC referencing. Okay, first of all, you have to reset. If you have any error, just reset it. And then after that, open the clamp. Okay, so after that, open the clamp. So this button, this is the reset button, right? Okay. So then after that, open the clamp. Okay. And if there is any workpiece in the machine, so take that workpiece outside. Otherwise, during the referencing time, collision will happen. Okay. So open the clamp and remove workpiece if any workpiece in the CNC machine. And then after that, close the door. And after that, using this option, close the door. Okay. So press the door close button continuously till make sure that your door completely closed. And after that, here in the keyboard we have a referencing button. This one, this button. Press the reference button. Machine will identify all the access form. Then go to Program Manager. Then after that, go to Program Manager. Okay. So yeah. So go to Program Manager, right? And then select program number 999. Where is that? Yeah, this one. Select program number 999. Okay. So select program number 999 and press the execute. So select program 999 and then press the execute button. Now the program is ready. Okay. In our screen, we can see program number 999 is loaded. Okay, that means machine is ready. And then after that, press this button. This button is the what is the meaning? The meaning is that CNC program start. Press this green button. Okay, so if you press this green button, machine will go to the home position. Okay, so this is another option. Okay, we'll try this. Then we have referencing using DNC to MES software. Okay. No need to use any WinNC. just open the yeah here. So this is one option. Another one is we can use DNC to MES software. Okay, first of all, press this reset error option. If any error was there, just reset it, and then after that, open the clamp. Okay, so for why you are opening the clamp to remove any whether you have to check whether any workpiece is available or not. Before doing the referencing, first of all, you need to remove the workpiece. So open the clamp and remove the workpiece. And after that, close the door and press this. Press the referencing button. Okay, close the door and press this referencing button. Okay, so machine will do the homing for all the access. Okay, then load program 999, right? Okay, load program, and you can once you load the program and press this start program. So now you loaded program number 999, then press this start program button. Now program 999 will work. CNC machine will continue home position so that the robot can use the CNC machine. Now referencing is completed, homing is completed. Now that means that now the system is ready. So here we have an option called a cyclic mode. Okay, if you enable this cyclic mode option, it will CNC position. This software will continuously monitor the CNC position. If you enable this cyclic, that means so that means when the robot will go to the CNC, before the robot going to the CNC, it will check whether the CNC is in safe position or the CNC is in home position. The software will check. So this is actually a safety feature. So do not turn off this cyclic option. This is very important. Then another option is called a set free button. If you press this set free button, now the present position will saved as home position. Okay, that is what is called a safe position. Then coming to the error on the HMIs. If any error is coming on your HMI screen, click the error and accept it. Okay, so now there is one error. Click and accept it. Okay, now you can see that now there is no error, right? Here there is one error. This red color shows error. Click and accept it. Now this screen you can see there is no error. So there is no error. CNC is connected. Program 999 ready. Everything is shown. That means CNC is completely ready. So coming to the automatic mode start. Before doing the automatic operation, okay. So when you press this automatic mode, what will happen? The conveyor belt will move, right? So the conveyor belt will move, the robot will move, CNC will operate. So When starting, do not stand directly at the ends of the belt or hold on to them. Keep enough distance. So failure to heed the information given can lead to injuries. So before going to the automatic mode, first of all, release the emergency stop button and press the blue reset button. If any workpiece is available in the machine, remove it first. Okay. And if any error will be on the HMI screen, so click and accept that error. If there is an error, it will be shown here in a red color like this. So this is an error. Okay. So once you rectify those error, press the reset button. Okay. System will go back to the home position. Okay. Once the reset button is flashing, press it. Okay. Then automatic button will be flashing. Press the automatic button. Now automatic mode will be selected, right? So now the automatic button changes to blue color, right? So that means automatic mode on. Okay, so the system is now in automatic cycle. As per the MES program, it will work. Okay, everything will be work automatically. Robot, conveyor, CNC, sensor, stations, everything will work automatically. If you want to stop the production, press this cycle end button. Okay. So the existing, once the system will complete the existing cycle and then it will stop safely. So when you press the cycle end, conveyor will stop, stoppers will extend, robot will stop and cycle will complete. Then coming to the writing on the RFID tag manually. So here we can change the RFID tag of the box. Okay, so we have a box, right? So in the box RFID, we can store the box number, product type, destination, CNC program, all the informations we can store. So go to the setup mode. And then after that, select the docking module. Place the RFID tag reader box. Press the read button. That time we can see the RFID data on your screen. Press the delete button to remove the old data. We can give new data. For example, new box ID, new box name, program number, operation number, etc. And then after that, press the write button. So the new data will be stored into that RFID tag. And then go to the parameter settings. These are the parameters of buffer mobile robot module. So robot program load. Okay. This means which program the robot should use. Parameter to box position. Okay. Where is the current position of the box? Parameter 3, CNC program. Then program number 4, robot program unload. After completing the machining, which program is required to take the box out? Okay, so far we have completed the referencing. Okay, so once we have completed the referencing, we can start the program. In order to monitor the CNC position continuously, enable the cyclic mode. If you have any errors on your HMI screen, click that error and accept those errors. Release the emergency button and press the reset. Select the automatic mode. If the automatic button is in blue color, that means system is in production mode. To stop, we can use cycle end option. So using the RFID tag, we can read or write. Through the parameters, we can change robot program, CNC program, box position, etc. So that's all about this CNC machining island. Okay, so let's see in the robot, the current robot is having batteries in three locations. One is in the arm, then controller, additional access. That means if access number 7 was there. Okay, if you change the battery, the robot controller should turn on. This is a must condition. If you turned off the controller and change the battery, the origin data will lost. If we can change the battery with the robot controller in on position, but if you change the battery uh, with the robot controller in off position, then what will happen was uh, your the origin data will lost. So this is a major problem. Once you change the battery, the next step is to reset. Okay, reset the battery counter. If you didn't reset it, then the controller will understand the battery was the old battery itself. Okay, then coming to the how we can set the origin. Okay, say for example, if the origin data was lost, okay, we have mainly two different methods. One is ABS method and the second one is mechanical method. Okay, so we can set the origin using ABS method or mechanical method. So this ABS method using encoder to set the origin. But in mechanical method, we will move the robot till mechanical stop and set the origin. As per the manual, they are saying that this method is more accurate, mechanical method. So to do this mechanical method, it's better to do this mechanical method with the help of two peoples. Okay. So why this two people is required means, so now we have two peoples, right? Why two peoples? Okay. So one will release the brake. Okay. So one will release the brake. Okay. And the other person will move the robot to its mechanical limit. So the procedure is very simple. Actually, we need 2 persons. Okay. So one will release brake, RELEASE. So what is this? So one will release brake and the second one will move the robot to its mechanical limit. To its mechanical limit. Okay. How we can release the brake? How we can release the brake? So we have in the robot controller, we have emergency socket, right? So behind the emergency socket, put the bridge connector. Okay, so 10A to 11A, 10B to 11B. Do the bridge. So in this way, we can release the brake. Okay. Okay, now one person will release brake and the second one will move every axis to its mechanical limit. For example, axis 1, axis 2, axis 3, axis 4, axis 5, axis 6. Okay. So move this to the mechanical limit. So we have 6 axes, right? Axis 1, 2, 3, 4, 5, and 6, right? When it reaches the mechanical limit, we have to save this as origin. We have to save this as origin. So once we have completed all the axes, okay, then now brake is released, right? So reset brake release and move the robot to its working range. Now we can move the robot in normal position. If we have extra 7th axis, okay, so in the job mode, move axis 7 to extreme right. After that, push till rubber stop, till it reaches rubber stop. This is what is the mechanical origin. Once completed this, run a program. So make sure that your speed will be, say, 10%. Do not give 100% speed. Okay, this is to check whether the robot is moving properly. Okay, even though you set your origin, and when you run the program, the robot is going in a wrong position. That means program position data will lost. So in that case, we should teach again. We should teach the robot again. Okay, so first of all, origin set, right? Then when you run the program, say from A to B, the robot is moving to another location C. That means we need to teach this position again. Okay, so here for example, in this case, in our program, pick the workpiece from box, right, to the CNC, right? So from A to B, right? If when you execute the program, if the robot is moving from A to C, that means the position was lost. Okay, we should reteach the position. Home position, pick, place, CNC loading, CNC unloading, magazine, conveyor, buffer, etc. Okay, we should use teach pendant to save everything. So what we discussed was, if you change the battery, okay, so this was one of the major problem. If your controller is in on position, your origin will be there. But if you turned off this controller and change the battery, your origin data was lost. Okay, once you change the battery, reset the battery. If there will be some origin error, use origin reset. We have two methods to set the origin. One is mechanical method and another one is ABS method. Okay, so using mechanical method, we need two peoples. So one will release the brake and the second person will move the robot to its mechanical limit. Okay, by releasing the brake. Then after that, run the robot with minimum speed. Okay, if the robot is, when you execute the program, if the robot is going in a different position, that means the positions you taught was not correct. So we should reteach that position again. Then only the robot will go in correct position.